Okay? So from problem number 3, we have to determine the moment of inertia of the figure shown below with respect to its centroidal axis. Also compute for its section modulus and radius of gyration. Okay, so we have here an unsymmetrical section. Okay, so the upper portion of the flange of this section have a 300 by 20 mm dimension. Okay, web we have 300 by 20, and then the lower flange we have 150 by 20. Okay, so to solve this, we need first to determine the location of our centroid for the whole section. Okay, this is unsymmetrical. Okay, so I will take my y bar from the bottom. Okay, I will take my y bar from the bottom. You can take actually your y bar from the top. Okay, but from my figure, I will take my y bar from the bottom. That is the location of the centroid of the whole section from the bottom. Okay, so let's say this is area 1, the upper flange for area 1, the lower flange for A2, and the web for A3. Okay, so area 1, that is 300 by 20, that is 6,000. A2, lower flange, that is 150 by 20, that is 3,000. And for the web, that is 300 times 20, the area is equal to 6,000. So the total area of the whole section is equal to 15,000. Okay, so solving for the y bar, okay, so the total area 15,000 y bar is equal to, okay, from the bottom tayo. Okay, so from the bottom, my upper flange, the centroid of my upper flange is on what distance from the bottom? Okay, so that is 300 plus 20 plus 10. Okay, since half nyan is 10. Okay, so 330. Okay, so we have times 330 plus lower flange, 6,000 area times the distance. So we have here the centroid of the lower flange. The distance of the centroid of the lower flange from the bottom is what distance? That is 10. Okay, so times 10. Plus for the web. For the web, 3,000 pala yung area ng lower flange, hindi 6,000. 3,000. Okay? And from the web, how about from the web? From the web, area is 6,000. Distance, okay? So yung distance po andito. Distance from a centroid ko is andito. And distance from the bottom, what is the distance? That is 300. So half of 300, 150. So hanggang dyan, 150. Plus 20, that is 170. Okay? So computing for the value of y bar, that is equal to 202 mm from the bottom. Okay? If you take y bar from the top, your y bar now should be equal to, that is 300, 340 minus 202. Y bar from the top is equal to 138 mm. Okay? Since on my diagram, my y bar is from the bottom, I will solve my y bar from the bottom. Okay? So my y bar is equal to 202 mm from the bottom. Centroid natin. Say, ito yung magiging centroid natin. Okay? So that is our y bar. That is 202. And this is our 138. Okay? Mali. Ito yung magiging XO natin. Mali yung diagram. Okay? That will be now our XO. Ito is 102. Okay? Ito yung magiging centroid natin sa web. Okay? Ito yung centroid from the upper, centroid of the web, and centroid of the lower flange. Okay, pag nag-solve kayo ng IY, the moment of inertia with respect to our y-axis, wala tayong ita-transfer since nag-coincides yung centroid nung full section doon sa upper, lower flange, and the web. So, hindi natin siya ita-transfer. Ang ita-transfer lang natin is pag nag-solve tayo ng IX. Okay? So, IX. This is now equal to, okay, let's start with the upper flange. That is 320 cube 12 plus the area 6,000. The distance. Ano yung magiging distance natin? Ano yung magiging distance natin? So, pagka ito yung kinuha mo from the top, sabi ko kanina, that is 138 from the top fiber hanggang doon sa centroid. Okay? That is 138 kasi 202 sa baba. So, if this is 138, ano yung magiging distance daw ng upper flange doon sa centroid ng buong section? Okay? So, kaya yan, 138 minus ilan to? That is 10. Okay? So, that is 138 minus 10 squared. Okay? Plus, the web, let's take our web, that is 20 times 300 cube over 12 plus the area, that is 6,000 times the distance. Ano yung magiging distance natin? Okay? Pagka ito, 202, tapos ito 150 plus 20, 170, ang distance dito, yan, is equal to ano? Ito yung hinahanap nating distance. Ano yan? That is 202 minus 170. Okay? So that is 202 minus 170. Okay? Okay? Squared. Huwag kalimutan yung squared. Plus the web. Yung web. Yung web. Ito. Ay, hindi. Yung upper flange. This is the web. Okay, the lower flange. For the lower flange. Okay? For the lower flange, that is equal to 150 times 20 cube over 12 plus the area, that is 3,000 times distance. Okay? So, if this is 202 from the bottom, yung y bar, ang location ng centroid ng lower flange is 10 from the bottom. Ang distance ngayon is 202 minus 10 squared. Okay? So, solving for the value of Ix, ang Ix natin is 260.34 raised to 6 mm to the 4. That is for the Ix. Okay? For the Iy, so for the Iy, we will not transfer. Okay? So, for the Iy, that is for the upper flange muna, that is 20, 300 cube over 12 plus for the web, that is 320 cube over 12, and for the lower flange, that is 20 times 150 cube over 12. Okay, so our Iy now is equal to 50.825 raised to 6. Okay, And to solve for the Rx, that is the square root of Ix over area, total area. We have our Ix, which is 260.34 raised to 6. And we have our total area, which is 15,000. So substituting the value, the square root of 260.34 times 10 raised to 6 over 15,000, our Rx now is equal to 131.74 mm. Okay? The same for Ry, that is the square root of Iy over A. Iy is computed, that is 50.825 times 10 raised to 6 times the total area, which is 15,000. Okay? So our Ry now is equal to 58.21 mm. Okay? So for the Sx, how about for the section modulus? Okay, so for the section modulus with respect to x, that is Ix over C. Ix is equal to 260.34 raised to 6. What is our C? Okay, if this is our 202 y bar, 202, and this is 138. What is our C? Okay, the farthest distance, so that is 202. Okay, substituting the value of Ix, our Sx now is 1288.811 raised to 3 mm to the cube. And for the Sy, that is Iy over C, Iy is computed, that is 50.825 raised to 6. How about our C? If this is 300, half of 300 is 150. Okay, substituting value of Iy, we will be getting the section modulus with respect to x, that is equal to 338.83 times 10 raised to 3 mm to the cube. Okay, so we have now our answers for the moment of inertia with respect to x, that is 260.34, Iy in mm to the fourth, the Rx, the Ry, and then the section modulus Sx and Sy. Okay?